Hello everyone, it is the Earth Science Reviewing the Essentials read-along. I think, if I remember correctly, we are on map scales now. Here we go. Map scales. Not all maps are the same size. A map of the United States, for example, might be as large as a wall or as small as a notebook. In addition, not all maps represent the same portion of Earth. One map might represent a country and another might represent one city within the country. So how can you tell distance on a map? A map scale relates the distance on the map to the distance on Earth. The closer the size of the map to the land it represents, the larger the map scale. Map scales are usually expressed in one of three ways. The first way is a general statement. For example, 1 centimeter represents 50 kilometers. The second way is to print a numerical statement such as the fraction 1 cm over 50 km, or the ratio 1 cm over 150 or 50 km. This is the same scale as in the previous sentence, but stated in a different way. In using this kind of scale, you can measure the distance between two locations in centimeters and divide by 50 to change to the number of kilometers that it represents on land. The third way to show map scale is by a line divided into equal lengths. The line is marked in units of length, such as kilometers or miles, to determine the real distance between any 2 points on the map. Place a sheet of paper on the map with the edge touching the 2 points in question. Make 2 marks on the paper to show the map distance between these points. Then move the paper next to the scale line to determine the actual size. Topographic maps. When you look at the map in figure 3-1, you see land and water, but you cannot identify mountains and valleys. In other words, you cannot use the map to learn about topography, which is the shape of Earth's surface. A map that shows the three-dimensional shape of Earth on a flat surface is called a topographic map. The highs and the lows of a land surface are also known as the relief of the land. Topographic maps use contour lines to show relief. Contour lines connect places that have the same elevation. Elevation is the height above sea level. You can think of a contour line as a step up or down to a new level. Contour lines never cross, just like makeup. The numbers on the contour lines are measured elevations. Some topographic maps use different colors for different elevations. The difference in elevation between two consecutive contour lines is called the contour interval. For example, a map with a contour interval of 10 meters will show contour lines at elevations of 0 meters, 10 meters, 20 meters, and so on. On any map, the size of the contour interval should be the same everywhere. The contour interval for a particular map depends on the relief of the land. Look at the landscape shown in figure 3-6. You may find the map a little confusing at first. It will become easier to read as you learn more about topographic maps with a little practice. With a little practice, you will be able to recognize landscapes such as hills and valleys from the shape of the contour lines. A steep slope, for example, is represented by closely spaced contour lines. The lines are close together become the elevation of a steep slope changes greatly over a short distance. A gentler slope is represented by contour lines that are spaced far apart because the elevation changes only slightly over a short distance. Contour lines usually form a V shape in a stream valley. They also form small closed loops around hilltops or depressions. You can tell whether the loops represent a hilltop or a depression by looking at the elevation numbers. If the numbers increase towards the center of the closed loop, the feature is a hilltop. If the numbers decrease, the feature is a depression. Most topographic maps also show natural features such as streams and lakes, as well as many features made by humans, such as roads, trails, and even some buildings. A key must be provided to describe the symbols used in the map. The United States Geological Survey publishes detailed topographic maps for all parts of the United States. You may want to use your local topographic map for locating places or planning travel. These maps are available from the United States government as well as from many local hardware and sports shops. A topographic map is a specific type of isoline map. An isoline map shows an area in which the same type of measurement has been made in several locations. On a topographic map, the measurements are of elevation. Other isoline maps show such measurements as temperature, air pressure, soil type, or age of bedrock. Gradient. You can use the information on a contour map to determine the average slope or gradient between 2 points on a landform. Gradient is defined as the change in elevation per unit distance. You can calculate the gradient between 2 points by using the following equation. Gradient equals change in elevation over distance. The change in elevation is determined by reading the elevation values on the contour map. The distance is determined by using the map scale. For example, suppose two locations are 5 kilometers apart. One is at an elevation of 2,400 meters above sea level. The gradient between the two above sea level, and the other is an elevation 26,000 meters above sea level. The gradient between the two locations is gradient equals change in elevation over distance equals 2,600 m minus 2,400 m over k over 5 kilometers equals 200 millimeters over k 5 kilometers equals 40 m over km. I'm sorry for that confusion if it confused you. This is the end of part 2. If you are interested in part 3 and so on and so forth, please continue to be subscribed to my channel and wait for my other videos. Should be in the next couple of days. Thank you for listening. My name is Amanda Buffalo. I am new to this and I appreciate your guys' time from whoever is listening. Thank you.